Alright, so here's a brief discussion on the CBSE Term 2 chemistry examination. And this document that will be contained in the video description, contains brief solutions to those questions. Let's discuss these questions. Overall, a pretty easy paper, nothing out of the blue. Everything was just fine. So anyways, the first question is, arrange the following compounds in increasing order of their properties as shown indicated in the bracket. The first one is reactivity towards HCN. Now, this is just a nucleophilic addition reaction, and we know that aldehydes are more reactive than ketones, and then ketones are more reactive than highly substituted ketones like this. So hence the order is this. And then next is acidic strength. So acidic strength, the only thing that differs here, and here, with regards to acidic strength, is the negative I effect of these substituents. So this is this substituent has the highest negative I effect. So that means this has the highest acidity. And this one has the lowest. This, in fact, has a positive I effect, which is bad for acidity. So hence I have just labeled these compounds for the ease of writing these answers. R is the least acidic, and P lies in between. The acidic strength of these substituted carboxylic acids is just dependent upon how many electron withdrawing groups you have. In the case of P, it has the most number of electron withdrawing groups, that is NO2, hence it is the most acidic, followed by Q, and then S with no electron withdrawing groups. And here you have OCH3, which is actually an electron donating group, which is bad for acidity. So hence this is the order. In the next question, we have an organic compound A with molecular formula C3H7NO on heating with Br2 and KOH, that means a Hofmann degradation reaction, forms a compound B. So we start with an amide, and since this is a 3-carbon amide, the simplest one that you can think of is this, and once you do its Hofmann degradation, you get this primary amine. This is ethanamine. Compound B on heating with chloroform and alcoholic KOH, this is carbolamine reaction. It gives you an isocyanide. So this is the isocyanide that you'll form, or you may have even written this as the following. Both are correct. And on treating with Hinsberg reagent, phenyl sulfonyl chloride, forms compound D, which is soluble in alkali. So this is just a simple nucleophilic attack here, and then the chlorine gets kicked out and you form this compound, and this is soluble in alkali because, well, this hydrogen can be replaced to get a negative sign there. So yeah. Next is define conductivity for the solution of an electrolyte. So this is a pure NCRT definition type question, and I've written here inverse of resistivity. So that is one thing you could have mentioned, or another thing you can mention is it is the conductance of a solution that is separated by unit length, in which the cell electrodes are separated by unit length, so that is L equals 1, and the area, the cross-sectional area, is also equal to 1. So in that case, the conductance and the conductivity will be same. Why does the conductivity of a solution decrease with dilution? Well, the number of charge carriers in this unit volume, that decreases with dilution, so the conductivity decreases. Let's move on to section B. Account for the following. Cr2+ is a strong reducing agent. Now, when it oxidizes, it forms Cr3+. Now, Cr3+, chromium itself, has the electronic configuration of S1d5, right? So Cr3+ now has an electronic configuration of, as you might have guessed it, D3. Cr plus 6 is D0, S0. So this is noble gas configuration, that is stable. And Cr3+, the immediate next oxidized species, has D3 in it, which is a half-filled T2G level. And this is mentioned in NCRT that a half-filled T2G level is brings stability to the cation. So that's why the products of the oxidation are more stable, and hence this is a strong reducing agent. The second one is titanium plus 3 is colored, while scandium plus 3 is colorless in aqueous solution. Now, in aqueous solution, you might as well assume it to be a weak field ligand. H2O is a weak field ligand. Then, what you can say, this doesn't really matter, you don't need to take it into account. Ti3 plus has an electronic configuration of D1. Scandium 3 plus is D0. D0 is no unpaired electrons. So if there are no unpaired electrons, then there are no energy transitions that can take place by shining light on that substance. So you won't see any color. So that's why scandium plus 3 is colorless. However, titanium plus 3 has one electron, and it is, let's say, in the T2G level. So it can be promoted from here to the EG level by shining light on it, and the corresponding light, the corresponding colors will be observed. Zinc, cadmium, and mercury are not called transition elements. A classic, easy question. They are not called transition elements because in the atom themselves and in the common cation, the common oxidation states, they have a fully filled d orbital, D10. The only exception to this rule is, this idea is Hg plus, but since it's a very rare oxidation state, we just don't consider it. Differentiate between the following: adsorption and absorption. So adsorption is a surface phenomenon. It is exothermic, bond formation takes place. Absorption is a bulk phenomenon. It's an endothermic process. Things go inside a material. In adsorption, things stick to the surface. Lyophobic and lyophilic salt. Well, phobic means repelling, philic means loving. Lyophobic salts are unstable, they are irreversible. By irreversible, I mean if you somehow filter out the dispersed particles and you re-add the liquid, it does not form the same salt. In case of lyophilic, that is the case, so it is a reversible salt. Next is multimolecular colloid and macromolecular colloid. So multimolecular colloids are formed by aggregates of molecules. So two really common examples are gold colloids and sulfur colloids. While macromolecular colloids are formed by large molecules as dispersed phases. Examples of this include proteins, or hemoglobin is one of those proteins, and yeah, plasma particles and things like that. Alternatively, you could have done these. So Zeta Potential. Now Zeta Potential, in the around the dispersed particles, you have a fixed layer of charges that stabilize it, and around that fixed layer you have a diffuse layer, and the potential difference between them is what stabilizes colloids, and that potential difference is the Zeta Potential. Coagulation is the aggregation of those particles. They come together. That brings instability to the salt, or to the colloid in general, and they ultimately precipitate. That is, they come out of the colloid. Why a negatively charged sol is obtained when AgNO3 solution is added to Ki solution? So when AgNO3 and Ki react, they form AgI, and AgI is a precipitate. It is a yellow precipitate, and the theory here is that precipitates adsorb the common ion they have from the solution. So the one ion they have in common is I minus. So I minus is adsorbed on AgI. So that forms a negative sol. All right. What happens when propanol is reacted with CH3 MgBr and then hydrolyzed? So propanol, and then you have the double bond O. You have CH3 MgBr, this attacks right there, and then you hydrolyze it, so it forms third butanol. Ethanol is reacted with excess of ethanol and acid. This forms an acetyl. If you did not have an excess, if you only had one equivalent, then you would have formed a hemiacetal. And acetyl looks like this. Let's say CH3COH. And then this is reacted with two equivalents of C2H5OH, this forms this acetyl. Methanol undergoes Cannizzaro reaction, so the corresponding carboxylate salt and the corresponding alcohol, a classic disproportionation reaction, we all know what it is. We react this acid chloride with an organocadmium salt, and this is exactly the same reaction is in many textbooks, including NCERT, and you simply have a single reaction. It does not go forward. Organocadmiums do not attack ketones. That's why it's a good way to produce them with this reaction. When you have propanol and then you do its Clemenson's reduction, which is zinc amalgam with concentrated HCl, that forms propane for you. You have cyclohexane carboxylate salt, and you add to it NaOH in presence of CaO. This is classic soda-lime decarboxylation, 3:1 ratio. This just removes this part and forms the cyclohexane. What is lanthanide contraction? Well, the contraction that is caused in the members of the periodic table that lie after lanthanide series. What is the cause of lanthanide contraction? Poor shielding by f orbitals. And write two consequences. There are many. Two of the ones that came to my mind when I was typing up the solutions are similar atomic sizes of 4D and 5D elements. That is, even though there is an extra orbit attached, the nuclear charge is increased so that the 5D orbital is pulled in, and that is bad. So it goes against adding in a new orbit, and both of these have similar sizes. Even there is a graph, a well-known graph that looks something like this. This is 3D, this is 4D, and 5D just grazes along here, the atomic sizes. Higher than expected ionization energies of 5D elements is the second one. And again, higher nuclear charge, more than what we would have expected. Which acid of the following pair do you expect to be stronger? Well, let me just change color. There are two blues here, which is not good. Okay. Which acid of the following pair would you expect to be stronger? You have a fluorine here. It has a even a decent amount of electron withdrawing effect, I- effect that is. Hence, this is a stronger acid. Arrange the following compounds in increasing order of their boiling points. You have ethanol, you have ethanol, you have ethanoic acid. Carboxylic acids have the highest amount of H bonding and van der Waals forces because of their high molecular weight. So they have the highest boiling point, followed by ethanol. Again, it has hydrogen bonding, but not as extensive as acetic acid. And acetaldehyde has almost negligible amounts of it. So anyways, that's the order. Give a simple test to distinguish between benzaldehyde and acetophenone. Two tests that come to my mind. Tollens test. It reacts with Tollens reagent, ammoniacal silver, reacts with aromatic aldehydes to give the corresponding carboxylate salt, but it does not react with acetophenone. Iodoform test gives a yellow precipitate with acetophenone. Remember, acetophenone looks something like this. So this group reacts with iodoform to form a yellow precipitate. With benzaldehyde, no such precipitate is formed. A key point of distinction here is that you cannot add in Fehling or Benedict's test. Since benzaldehyde is an aromatic aldehyde, those tests cannot be used to distinguish. Which will undergo faster nucleophilic addition reaction, acetaldehyde or propanol? Well, again, aldehydes win against higher substituted ketones. What is the composition of Fehling's reagent? I should have written it over here. The first one, Fehling A, is just copper sulfate. And Fehling B is two things actually. An alkali, usually used is NaOH, plus something known as Rachel's salt to provide stability to the precipitate. Draw the structure of the semi-carbazone of ethanol. So the semi-carbazone is formed using this compound. Let me just write it right here. and this reacts with ethanol. And then again, the imine, the classical imine formation, and you get this. Give reasons that the ammonolysis of alkyl halides is not a good method to prepare pure primary amines. Well, again, we know this. If you start with Rx, let me just use a better color here. If you start with Rx plus NH3, you do get RNH2, but then this can again attack an Rx to form a secondary amine, and this will give you a tertiary amine, and that will give you a quaternary ammonium salt. Not good. A mixture of ammonia derivatives is formed. Aniline does not give Friedel-Crafts reaction. The reason is pretty simple. You have a Lewis acid that you will always use with Friedel-Crafts reaction. The most common is AlCl3. Aniline is a base. It is also a Lewis base. So it can attack AlCl3 to form this compound. Let me just draw that compound a bit more distinctly. Now you have a nitrogen that has a positive charge on it. This is highly deactivating, very, very bad for electrophilic aromatic substitution. Hence, no such reaction is formed. Although NH2 group is orthopyrite directing in electrophilic substitution reactions, yet aniline on nitration gives good yields of meta-nitroaniline. So again, a similar reason as part 2, whenever you have NH2 group, it reacts with the acid. Nitration is done using the nitrating mixture. It contains strong acid, and it forms the anilinium ion. Anilinium part is strongly deactivating, similar to this, and thus you have a meta direction. And the ratio, you might as well remember the ratio. Para is 51%, meta is 47%, and ortho is 2%. Using valence bond theory, predict the hybridization and magnetic character of the following. So this is hexafluorido-cobaltate 3, and cobalt has an atomic number of 27, hence the electronic configuration is argon, then 3d7 4s2, so 18 plus 9, yeah, 27. And the oxidation number in this case is plus 3, then plus 3 minus 6 is equal to minus 3, so yeah, plus 3. And CO plus 3 has 6 d electrons, and fluorine is a weak field ligand, so that means you will have an outer orbital. So you have sp3d2. So the d orbitals, let me just draw that first. The d orbitals of cobalt, and then in the rest sp3d2, those will get hybridized and then accept the lone pairs from fluorine. So that you have 4 unpaired electrons. The magnetic moment is square root of 24, 4 into 6. And this is also, since they have asked the magnetic character and not the magnetic moment, the magnetic character is paramagnetic. Write the IUPAC name of the following complex. So arrange this in ascending order alphabetically. So you have dibromido bis ethane 1,2-diamine, cobalt 3. You could have added in the ion right there, but I don't think so that was needed. How many ions are produced from the complex in the solution? So this is a complex ion. This is not complex. This will dissociate into 2 Cl minuses and 1 complex ion. This will not dissociate further. So you have 3 ions in total. Calculate delta Rg and log Kc for the following cell. So this cell, they have given the E naught already. So you can just put that in this equation and just multiply this. It will give you an answer. Let me just do that for you right now. And the value of n is 2 because 2 electrons are being transferred in both of the redox, so both in reduction and oxidation. 2 electrons are being transferred. 2 into 96500 into 1.05 gives you 202. So this is 202.65 kilojoules per mole of nickel. And then you have to find out the value of log Kc. So we know RT ln Kc equals NFE. And I missed the 2.303 here. But anyways, this part right here is just equal to 59 millivolts or 0.059. And yeah, just to multiply this. So 2.1 divided by 0.059 is approx 35.6. That should be almost your answer. Or the second part of this question, the second alternative, is calculate the EMF of this cell. So the value of N here again is 2. The equation of this cell, I forgot to mention that right here. Let me just do that for now. Fe plus 2H plus, I'm not writing solid and aqueous here, forms H2 and Fe2 plus. So 2 electrons are being transferred. So the value of N is 2. The value of Q, the reaction quotient, just plug in everything. Fe is a solid, so no need to worry about that. H2 is a gas with pressure 1 bar, so again, no need to worry about that either. And you get the value of Q to be equal to 10. Plug that into the Nernst equation, put N equals to, yeah, and you get the answer to be 0.41 volts. All right, the last question. What is the effective temperature on the rate constant of a reaction? We could have read this paragraph, but it doesn't seem necessary. Anyways, what is the effect of the temperature? Arrhenius equation, I think it was not in the curriculum this year, but anyways, this is something that most of the people would already know. But more generally, you could have written that as temperature increases, the rate constant increases. The empirically, an increase of 10 degrees or 10 Kelvin on the temperature chart results in a 2x fold multiplication of the rate constant. So that might be something you have wanted to mention. For a reaction, the rate law is given by this. What is the order of the reaction? So we just add in these powers, you get 5 by 2. What is the order and molecularity? How order and molecularity are different for complex reactions? Well, this thing is not defined, since it is only defined for elementary reactions. Remember, molecularity is how many atoms or molecules come together at the same time to form the transition state and then the product. So this is not defined for a complex reaction. The order is defined, and it is dependent on the rate determining step, whatever it is. We write the order dependent on that. The last part of this question, again, 2 alternatives. The first one is a first order reaction has a rate constant. This is this. How long will 6 gram of this reactant take to reduce to 2 grams? So you can write this a bit more extensively. A naught by A divided by K. This is the time required. So the natural log of 3 divided by 2 into 10 to the power of negative 3. You will write this as 2.303 into the log of 3. So that is 0.4771. And then you divide this by 0.002. It gives an answer of about 549 seconds. So approximated to 550 seconds. Half-life of radioactive decay of carbon-14 is this. An archaeological artifact containing wood had only 75% of this 14C found in a living tree. Find the age of the sample. So again, the same thing. And A in this case, the concentration or the mass, whatever you want to use, is 3/4 of what it should have been. And K right here can be written as natural log of 2 divided by the half-life. So you write it here, and you get T equals log of, actually natural log at first. So natural log of 4 by 3 divided by natural log of 2 into half-life. And you can also write this as log of 4 by 3 divided by log of 2 into T half, since you can change the bases if you do them both at the same time. And then, yeah, plug all these values in. I might as well just do it right now. So log of 4 by 3 is something divided by log of 2 something into the half-life is 6930. That is awfully similar to 0.693, natural log of 2. But the answer comes out to be 2876 years, approximately. So, yeah, that's it. Easy paper, nothing extraordinary, almost completely doable.